This part of the review is simplifying rational expressions. So we're going to look at basic rational expressions first, and then we're going to look at a little more complicated rational expressions that contain polynomials. So let's look at simplifying these simple rational expressions. What we're going to do first is we're going to look at the constants. So I'm going to see if I can reduce the 3 over 6. I'm going to look at reducing the constants, and 3 over 6 does reduce to 1/2. So now let's look at the variables. If I look at the variables, I have x to the 5th over x squared. If you remember, that's the quotient rule for the law of exponents. Whenever you have an exponential expression divided by another exponential expression that has the same base, x to the 5th, x is our base, x squared, x is our base, you subtract the exponents. So 5 minus 2 is 3. We really don't need that 1 up there. You can leave it if you want to, but that means x cubed goes on top after we reduce these, and so I'm left with x cubed over 2. 1/2 x cubed. So let's look at part B. Part B, I'm going to look at, and again, these are all monomials. That means they're all multiplied together. There's no addition and subtraction in here, so I don't have to worry about other factoring. I can go straight into constant over constant and base over base. So 25 divided by 5 is going to give me 5. I have x to the 12th over x to the 7th. Again, by the quotient rule, when the law of exponents, 12 minus 7 is 5. We subtract, so that's going to give me x to the 5th. And then I'm going to look at my y values, and I've got y squared over y, which is the same as y to the 1st. 2 minus 1 is 1, so I have y to the 1st. And that is the solution to this, or that's how you simplify this expression. Let's look at the last one. I have 6 over 3, and that's going to give me 2. I've got x over x squared. How is that going to work? Well, if I have x over x squared, what that means is I'm still going to do the quotient rule, 1 minus 2, and that's x to the negative 1. Okay, I'll go ahead and write that, x to the negative 1. We're going to do something with that, though, in a little bit. And then my last one, I've got y to the 14th. Y to the 14th. Now, I don't have anything to couple with that, so it's just going to stay y to the 14th. I don't want to have a negative exponent. So how do I get rid of that negative exponent? Well, if you remember, if I give you an example, x to the negative 1, that is the same thing as 1 over x to the positive 1. Whenever you have a negative exponent, if you put it in the other part of the fraction, the exponent becomes positive. So if I have a negative exponent on top and I move it down below, it becomes positive, and vice versa, same thing. If I had 1 over x to the negative 3, I could move that up top and make that x to the 3rd. So that's how that works. So I'm going to change this. I'm going to leave the 2 and the y to the 14th on top, and I'm going to put that x on the bottom to get rid of that negative exponent. And that's how you simplify the simple monomial rational expressions. So let's look at some rational expressions here where we have trinomials. That means we're going to have to do some factoring. So if you look at this, let's factor these. My a value here for each of these is 1, so it's going to be pretty simple. I'm going to do 2. I want to see if I can factor anything out. There's no common factor between 1, 3, and 2, so we're going to have to factor here. I'm going to take the factors of 2 that are going to subtract to give me 3. And that is going to be the only options we have, or sorry, add. Not my bad, add. 2 factors that are going to add to give me 3, and that's 2 plus 1. So I'm going to rewrite the top as x, 2, and 1. And since both terms are positive, it's just going to be plus and plus. That's the only way I'll get a positive 2 is positive times positive, and then still get a 3x. Positive 2x, positive 1x. So let's look at the denominator now. Same thing, my a value is 1, so I'm just going to use the 10. I'm going to take the factors of 10, and I'm looking for 2 factors of 10 that add to give me 7, and that's 5 and 2. So I'm going to rewrite the bottom as x and 5 and 2. Since my b value is positive, I know the 5 has to be positive. And since my c value is positive, they both have to be the same. So there is my rational expression. But if we were graphing this, there's a hole. You can see the hole. Remember, whenever you have two factors that are identical and they cancel, that's a hole in the graph. But we're just simplifying here, so we're going to cancel them out like we would do any other values that are the same. And that's going to leave us with a final answer of x plus 1 on top and x plus 5 on the bottom. And that is the simplified form of 23a. We're not graphing. We're not looking for holes and asymptotes. There is a hole here at -2. The vertical asymptote is at -5. We can discern all that information, but we're not paying attention to it as a function right now. We're just looking at it as an expression. All right, so let's look at the second one. My a value is not 1. Do I have anything I can factor out? No. So I have to do MF DARM. Okay, remember MF DARM? Multiply a times c, that gives me 30. So I'm looking at two factors of 30 that are going to subtract to give me a 1. That's what's assumed to be in the middle. And you can write out all the factors of 30. There's 30 and 1, 15 and 2, 10 and 3, and there we go, 6 and 5. 6 and 5 are going to subtract to give me that 1. So I'm going to write up top x and 6 and 5. And because my b value is negative, I'm going to give the 6 a negative. And because my c term is negative, we have to have a negative times a positive. But we're not done yet. When the a value is not 1, you're not done yet. You have to complete the MF DARM process. So what we're going to do next is you multiplied, you factored, and now we've got to divide by a. The a term is 2. I'm going to divide this by 2. So this one reduces, x minus 3. This one does not reduce. So what are we supposed to do when it doesn't reduce? Well, you divide by a, you reduce, and then you move. So that 2 is going to go in front. So it's 2x plus 5. So that is what the top looks like. X minus 3, 2x plus 5. Let's look at the bottom. We're going to be doing the same kind of thing. A times c, 4 times 5 is 20. So I'm going to be looking, at factors of 20 that subtract to give me 8. And that's going to be 10 and 2. So I'm going to write my factors. I'm going to write them underneath. I've got x and 10 and 2. Since my b value is positive, the 10's got to be positive. Since my c value is negative, this has to be negative because a positive times a negative. But since our a value is not 1, we have to complete MF DARM. And the next thing is to divide by a. So your a term is 4. Divide by 4. And then I see if I can reduce. I can't really reduce anything, so I have to go to my next step, which is to move. So that becomes 4x plus 10. Now you can reduce this, and you'll end up getting the correct answer as well. You get 4x plus 10. And if I end up getting 4x minus 2 here, look what happens. 4x times 4x is 16. That's not what we want. So what do we have to do first before we move? MF DARM, reduce. Okay, a lot of you forget to reduce. You go straight to that one. So I'm going to go x plus, and 10 over 4 is 5 halves, and then x minus 1 half. Now I'm ready to move. So I'm going to move them now. Move the 2, move the 2, and then I have 2x plus 5, and I have 2x minus 1. And those are my two factors for the bottom. Now, looking at this expression only, because that's our final, not our final, but what we came up with, you do have something you can reduce. There's a hole there. So those can cancel. So that'll leave me with x minus 3 on the top and 2x minus 1, you don't have to write the parentheses, on the bottom. And that is the simplified form of B.